Let's keep talking about client density. This is the second video. We're still talking about the issue where you have many users in the same cell sharing the same airtime. The other approach that you will need to address this issue is designing for more channels. So when designing for more channels, you must prefer using 20 MHz channels to get as many channels as possible. For instance, if you're in the US, talking about the 5 GHz band, you can have up to 25 different 20 MHz channels. So ideally, you must have more channels than access point in your deployment in order to avoid co-channel interference. You don't want co-channel interference, so ideally, your deployment will look like this. Use different channels, never repeat a channel. So if you can do that, go for this. But if you cannot, and you have to repeat your channels, make sure that the power coming from this access point to the other access point that is using the same channel is no greater than minus 82 dBms. If you achieve that, these two access points will be working practically isolated from each other, which is a good thing. You can also enable a feature that is known as RxSub, set it to minus 78 dBms. If you use RxSub, you will be ignoring frames coming from these far devices that are using the same channel, and you will be ignoring those frames. So in that case, your design will work even better. So this is an example where you are using too much power in order to transmit from this access point, and you will be reaching this other access point with transmission power of more than minus 82 dBms, which is bad. So you don't want to fall into this scenario. This is an example. So if this happens, these two access points will be actually be sharing the same spectrum, sharing the same airtime. So in summary, they will be sharing the same bandwidth. So you will be splitting your bandwidth between two. You don't want that. No matter what value you use for RxSub, try to avoid this at all cost. Use another feature, a Cisco feature that is known as DCA, in order to minimize co-channel interference. DCA will get the best channel plan for you automatically. These are the DCA settings for high density scenarios. You can also use a specific type of access points that have something that is known as dual band sub-radios. These access points have two radios, one that is always transmitted in the 5 GHz band, and another radio that can transmit either in 2.4 or 5 GHz band. So you can have two modes of operations. The first mode of operation, you have one radio that operates in the 2.4 GHz band and the other in the 5 GHz band. But if you make this radio operate in the 5 GHz band, you will enable a mode that is known as dual 5 GHz mode. Use another feature that is known as flexible radio assignment, that we will be talking about later on. So if you use the dual 5 GHz mode, you can have this macro mode where your access point will be radiating two cells, a micro cells and a larger cell, and where these cells will be using different channels. And if you attach an external antenna to your access point, this external antenna can radiate one cell and your access point can radiate a different cell, both using different channels. This is known as macro mode. Avoid this what is known as a 2.4 to 5 GHz power imbalance, and use TPC in order to avoid this. In this example, for instance, this radio is transmitting in the 2.4 GHz band, but transmitting with more power than this radio that is using the 5 GHz band. In this case, your dual band capable devices will try to associate with the access point that is transmitting with more power. So in this case, you will have more devices using the 2.4 GHz band, and this access point will be busy, whereas this access point will be idle. You don't want this scenario, so use TPC in order to avoid that.